The Sun, our very own neighborhood star, has been the subject of many scientific investigations over the years. This year has seen a major resurgence in solar exploration with a wave of missions diving straight into the heart of our solar system's blazing giant. These missions are packed with cutting-edge tech and bold objectives, and they've taken solar science to new heights and new temperatures. Here's a deep dive into the latest efforts to unlock the secrets of the Sun. Parker Solar Probe, a journey to touch the Sun. NASA's Parker Solar Probe is the undisputed champion of solar missions. Launched in 2018, it is on a 7-year journey to get closer to the Sun than any spacecraft has before, within a mere 3.8 million miles of the solar surface. To put this in perspective, if Earth were scaled down to the size of a football field, the Parker Solar Probe would be at the 4-yard line, while the Sun would be at the opposite end. By 2024, the probe completed its 20th close approach to the Sun, setting records for both proximity and the intensity of data collection. The probe's mission is to decode the mysteries of solar winds and the corona, the Sun's outermost layer that is inexplicably hotter than the Sun's visible surface. The Parker Solar Probe has already provided groundbreaking insights, such as the observation of particle acceleration mechanisms, which have puzzled scientists for decades. Solar Orbiter, the Sun's pole dancing partner. Meanwhile, the Solar Orbiter, a collaboration between NASA and the European Space Agency, is taking a more picturesque approach. Launched in 2020, the Solar Orbiter is giving us the first ever images of the Sun's poles, a region previously hidden from direct view. This is critical for understanding the Sun's magnetic field, which plays a key role in driving solar activity such as solar flares and coronal mass ejections. These phenomena can disrupt satellite communications and power grids on Earth, making the Solar Orbiter's observations vital for space weather forecasting. The Solar Orbiter's orbit allows it to tilt and capture images from various angles, providing a three-dimensional view of the Sun's activity. Its ability to hover over the Sun's poles for extended periods allows for in-depth observation of solar dynamics that influence the entire solar system. Aditya L1, India's first solar sentinel. India joined the solar exploration race with its very own Aditya L1 mission, which aims to study the Sun from a unique vantage point, Lagrange Point 1. This is a location in space where the gravitational forces of Earth and the Sun balance each other, allowing Aditya L1 to maintain a stable position for continuous observation. Launched in 2023, by 2024, Aditya L1 had already captured incredible high-energy X-ray emissions from solar flares and snapped full-disk ultraviolet images of the Sun. These observations are crucial for understanding the Sun's influence on space weather, particularly how solar wind flares interact with Earth's magnetosphere. The mission's solar wind ion spectrometer and other instruments are providing unprecedented data that will contribute to global efforts in space weather forecasting and solar science. Heliosphere and beyond. The big picture. While individual missions like Parker Solar Probe and Aditya L1 provide focused data, the ultimate goal is to understand the heliosphere, the vast bubble created by the Sun's solar wind that envelops our entire solar system. The heliosphere acts as a protective shield against cosmic rays, and its dynamics influence space weather throughout the solar system. The Parker Solar Probe's up-close measurements, combined with the Solar Orbiter's observations, are helping scientists refine their understanding of the heliosphere's boundaries. This is particularly important as the Sun approaches its solar maximum, a period of heightened solar activity. The data collected during this time will be invaluable for predicting solar storms and their potential impacts on Earth. Space weather forecasting. No more solar surprises. You might think solar flares are just another pretty cosmic light show, but they can cause serious trouble. Solar flares and coronal mass ejections release massive amounts of energy that can interfere with satellite communications, GPS systems, and even power grids on Earth. The Parker Solar Probe is helping to predict space weather by studying the Sun's corona, where these flares originate. By understanding the mechanisms behind solar flares, scientists can develop more accurate models to forecast space weather events. This is not only important for protecting our technological infrastructure, but also for the safety of astronauts and spacecraft operating in space. Solar science's hot questions. Why so hot? The Parker Solar Probe and Solar Orbiter are both grappling with one of solar science's hottest questions. Why is the sun's corona so much hotter than its surface? This is like walking away from a campfire and feeling the temperature rise as you move farther away. Scientists have been puzzled by this phenomenon for decades, and the Parker Solar Probe is getting closer than ever to finding answers. By collecting data from within the corona, the probe is helping scientists understand how energy is transferred from the sun's surface to its outer layers. This research could lead to breakthroughs in our understanding of stellar physics and the processes that drive solar activity. The magnetism of the sun, nature's biggest dynamo. Solar Orbiter's unique orbit allows it to map the sun's magnetic field in ways that were previously impossible. By examining the poles, where the sun's magnetic field is most active, Solar Orbiter is shedding light on how this massive dynamo operates. The sun's magnetic field is responsible for many of the sun's most dramatic phenomena, including solar flares and coronal mass ejections. Understanding the sun's magnetic field is not only important for solar science, but also for understanding the broader impacts of space weather on the entire solar system. The data collected by Solar Orbiter will help scientists refine models of the sun's magnetic field and improve our ability to predict solar activity. Future challenges. The sun isn't giving up its secrets easily. Despite all these advancements, the sun is still playing hard to get. Scientists expect that as these missions continue, they will uncover even more mysteries. Every answer seems to lead to more questions. For example, why does the sun's magnetic field flip every 11 years? What exactly triggers solar flares and coronal mass ejections? These are just a few of the questions that scientists hope to answer with the data collected by Parker Solar Probe, Solar Orbiter, and Odysseus L1. As these missions continue to send back data, scientists will be able to refine their models of solar activity and better understand the processes that drive the sun's behavior. Vigil on the horizon. Europe's new eye on the sun. The European Space Agency's Vigil mission, set to launch in the coming years, will offer an unprecedented eagle-eye view of the sun. Vigil is designed to monitor solar activity in real time, offering improved space weather forecasting. Pairing Vigil's data with those from NASA's missions could help protect Earth and its technological infrastructure from the sun's more dangerous outbursts. Vigil's unique vantage point will allow it to observe the sun from a perspective that complements existing missions, providing a more comprehensive view of solar activity. This mission will be a critical addition to the global effort to monitor and understand the sun's influence on the solar system. And that wraps up our deep dive into the latest solar missions, uncovering the sun's secrets. If you found this video as fascinating as we did, make sure to give this video a thumbs up and hit that subscribe button to stay updated with all things cosmic. Thanks for watching, and we'll see you in the next video.